Alright, so section 2.5 is over interpreting graphs. So two things that we want to look at are making appropriate graphs for our data, and also what we mean by misleading graphs. So if you recall, right, from our previous two sections, right, we talked about appropriate graphs depending on what type of data we have, right? So if we have numerical data or quantitative data, what would be appropriate for that would be a dot plot, a histogram, or a stem plot, right? But if we have categorical data, so data that's being split into categories, what would be appropriate here would be a pie chart or a bar chart, right? And one other chart that we talked about for categorical data is a special type of bar chart, and remember that was called a Pareto chart. Right, so we could add that to your table if you wanted, right, or make note of it. Also, we want to talk about appropriate measures, right? When depending, and this also depends on what type of data that we have, right? So remember, if we have numerical data, we want to think about the shape, the center, and the spread, right? So those should be the three points of emphasis. But if we have categorical data, right, we're looking at two specific things. We're looking at the mode and also the variability. Right. So then for misleading graphs, right, one thing to keep in mind is that even if you have a well-designed graph, they can also be misleading, right? And this could be intentional or not intentional, but something that we need to be aware of. So it can play tricks on our eyes to make us try to reach a specific conclusion, right? And there were some examples in the text that I'd like to pull up, right? Right, so if we go into my math lab or my stat lab, alright, so we can go to multimedia library, and let's pay, so we want let's grab the textbook. Alright, so this we're looking for figure 2.30. So here, right? So this for example, right? So it reads here. So A says this bar chart apparently shows a dramatic decline in the number of violent crimes since 2007. The origin for the vertical axis begins at about 1.2 million, not at 0, right? So one thing you want to notice here at the bottom is that we have 1.20 starting there, then going up by 0.05 each time, right? So changing our vertical axis can make things look small, like more far apart or close together, right? So we can make any values look close or far apart, which means if we want to argue one specific case, we can just change the vertical axis and make that happen, right? So the graphs aren't lying, right? So like A and B, these graphs are displaying the same exact information, right? They're both correct. Just one has an emphasis that that the crime rate has dropped dramatically, and one on the right, part B, plays a trick on our eyes that the violent crimes haven't changed much over the years, right? So you have to keep that in mind, right? And then the other misleading graph that was talked about in the PowerPoint was this figure 2.31, right? So we have A, B, C, and D, right? And actually, if you go to the next page, right, it explains these three graphs, or four graphs, right? So it says here, right? So in figure 2.31, the heights of the homes are indeed proportional to the sales numbers, but our eyes react to the areas instead, right? So area being length times width. So what's the area that the picture is taking up? So the smallest house is 69% as tall as the largest house because 4.9 is 69% of 7.1. Right? So if we're just talking about the height of the homes, that's accurate. But again, our eyes, our brains want to focus in on the area. So the area of the smallest house is only about 48% of the largest house. Right? So our tendency to react to area rather than to height exaggerates these differences. Right? They make it seem a lot different than what we would expect. Right? Than what's actually being presented. So we have to keep this in mind when looking at data. Right? And also, while I have this up, I wanted to bring up one particular problem. So this was in 2.5 homework. Right, so I wanted to look at question 1, right, and talk about this a little bit. So it reads, the accompanying graph shows the distribution of data on whether houses in a large neighborhood have a garage, right? So it says a 1 indicates that the house has a garage and 0 indicates it does not have a garage, right? So our variables are dichotomously decoded, right? If you recall, that means that we are using zeros and ones to represent like a yes or no, a true false type of setup. So the question is this a bar graph or a histogram? Then the second question is, how could the graph be improved, right? And notice to get this up, I just clicked on this image to pop up the graph. And if you want to see it more closely, I can click on the plus sign to magnify, right? So we can get a closer view. So along the horizontal axis we have garage, and here's my 0 and 1. Notice my bars are touching. And then along here we have frequency, so 10, 20, and going up by 10 all the way to 80, right? So we have bars touching, and along the axis we're talking about frequency. So this type of graph would be a histogram, right? So C, the graph is a histogram because the bars touch, right? So we can check that. We got that right. So then the next part is, how could the graph be improved, right? So A, this is the graph can be improved by changing the units on the vertical axis to relative frequencies. This would show the proportion of the houses in the neighborhood with or without garages instead of the frequency of the houses, right? B says the graphs could be improved by containing more categories under garage to show more variability in detail. For example, 1 car garage, 2 car garage, etc. could be added. C, the graph could be improved by switching the positions of the garage categories, right, so forth. And lastly, D, the graph could be improved by making it a bar graph or a pie chart. This change would make the variable garage be seen as categories, not as numbers, right? So if we look at this chart a little more, right, if you think about this, our variable here is someone has a garage or not a garage. So in other words, they're being split into groups, right? So we're putting people in a group that has a garage and people that doesn't have a garage. So this chart, this graph could be improved by making it a bar graph or a pie chart, right? So a histogram is used for numerical data, where a bar graph or a pie chart would be more appropriate for a qualitative piece of data, categorical data, right? So our variable is categorical, so we should put it in this format, right? All right. So I wanted to talk about that question, and then lastly, I just wanted to point out on Canvas. So underneath section 2.5, I did post a link here for statistics how-to and misleading graphs. So I would also click on this and watch this video presented here, right? So it's just a little over 5 minutes long, and this shows some more details, some real-world examples of misleading graphs. I think it's well done. And also, while we're on this site, I've explored this site a little bit, and I've been impressed with this site. So this might be a excellent resource for you to check out if you have some difficulties. All right, well that's all I have for this section. So far with the first two chapters, it's mainly been a lot of definitions for the most part, right? So in chapter 3, we'll start doing a little more mathematics, right, with some calculations. All right.